You are standing in line at a coffee shop when you notice the two people in front of you. One is a tall man with dark skin, dark eyes, and a deep voice. The other is a short woman with pale skin, bright blue eyes, and a high-pitched voice. They are laughing, and in a split second they both sneeze, turn their heads, and gesture with their hands in the exact same, peculiar, synchronized way. You chuckle and ask if they are close friends. They turn to you, smile, and say, "We are actually identical twins." You laugh, thinking it's a joke, but they insist it's true. You're completely bewildered. How can a biological male and female of different races be identical twins? And then your alarm goes off. It was just a dream. You just lay there heart racing and dumbfounded, and you ask yourself, does a pair of twins like that actually exist? Statistically, no. But that raises a more interesting question. Out of the roughly 1.6 million twins born every year, what would the rarest possible twins look like? To answer that, we need to break the biology of twinning down trait by trait, starting with how they are conceived. To start, they are twins. Globally, twins make up about 1.2% of all births, or roughly 1 in 80. But they aren't just any twins. They are sesquizygotic, or semi-identical twins. This happens when a single egg is fertilized by two different sperm, creating 3 sets of chromosomes. Usually, this is fatal. But in extremely rare cases, the cells divide and rescue the embryo, creating 2 babies who share 100% of their mother's DNA, but only about 50% of their father's. Only 2 cases of sesquizygotic twins have ever been confirmed in medical history. Let's estimate the probability of this occurring at 1 in 50 million births. Combining these, our twins have a 1 in 4 billion chance of existing. Now, let's make it even more mind-boggling. What if those 2 sperm came from 2 different men? So this is called heteropaternal superfecundation, which usually happens with fraternal twins. But for semi-identical twins, it would mean 2 different men's sperm fertilized the exact same egg at the exact same microsecond. So this has never been officially documented in human history, but theoretically, the probability of this happening is about 1 in 100 million. Combining this, our twins now have a 1 in 400 quadrillion chance of existing. Next, let's make them mirror image twins. Mirror imaging occurs when the fertilized egg splits late, around 9 to 12 days after conception. This causes them to develop asymmetrical physical traits on opposite sides. If one is right-handed, the other is left-handed. Their hair whirls in opposite directions. But let's take this to the extreme. Situs inversus, this is a rare genetic condition where a person's major visceral organs are completely reversed, like a mirror image of normal anatomy. Their heart is on the right side, their liver on the left. This occurs in about 1 in 10,000 people. Applying this to just one of our twins, the chance of this specific mirror image trait is 1 in 40,000. Now, our twins have a 1 in 16 sextillion chance of existing. Let's add another layer. One of these twins has complete albinism, while the other does not. Albinism is a genetic condition caused by mutations in the genes responsible for melanin production. It occurs in about 1 in 20,000 people. Since our twins are semi-identical and have different fathers, only one of them inherits the active recessive genes for albinism from both parents, leaving the other with typical pigmentation. Combining this, our twins now have a 1 in 320 septillion chance of existing. Finally, let's give one of them the Bombay blood phenotype. Most people have A, B, AB, or O blood types, but those with the Bombay phenotype lack the H antigen, a building block required to make these blood types. They can only receive blood from another Bombay phenotype individual. It is incredibly rare, occurring in about 1 in a million people globally. This brings the total probability of our twins existing to 1 in 320 nonillion. To recap, the rarest twins we created so far are sesquizygotic, heteropaternal, mirror-imaged with situs inversus, discordant for albinism, and one has the Bombay blood phenotype. In other words, the total probability of these twins existing is 1 in 320 nonillion. To put that into perspective, the number of stars in the observable universe is roughly 1 septillion. If you counted every single grain of sand on Earth, you would need to have 42 trillion Earths to get to that number. And this is not even the rarest twin pair you can make. There are still so many traits that hold countless possibilities: conjoined anomalies, extreme chimerism, and diverse cognitive traits. The point is that every single one of us is unique. Even if you aren't part of an astronomical twin pair, the odds of you existing exactly as you are today are already beyond calculation. So, appreciate your own rare existence because there is truly no one else like you. Well, unless we count me, the guy in the blue hoodie, still sitting here in this coffee shop staring blankly at my half-empty cup. Waking up from a dream like that makes you look at the world a little differently. We spend so much time searching the cosmos for anomalies, calculating astronomical odds, and looking for rare miracles, when the biggest miracle of all is already here, sitting right in front of us. Because the truth is, I don't need to run a complex genetic equation to know how incredibly lucky I am to have your attention right now. Oh, out of the 8 billion people on this planet, you are a 1 in a septillion match for this screen, and that is a statistical masterpiece. So keep on being your wonderfully unique self, stay rare, and I'll see you in the next one.